Good morning. We are Team 18, and our topic is Intelligent Badminton Insights, where we did tracking, detection, and shot classification in single badminton. Badminton is a very fast-paced soap sport, and where every move counts. And analyzing each matches manually is very time-consuming. So we used AI, and we detected three of the key features areas, like tracking the shuttlecock and the players, detecting the court, and creating a top-down view, and classifying different types of shots. So first, we will discuss about the shot detection thing, and main our objective is to identify the strokes type, the types of the badminton shots, which for example are clear, drop, smash, lift, drive, etc. And we did 18 different type of shots, and we systematically analyzed each of the matches. Our primary method, first of all, we detected the player's position using the tools like open pose. Then we use the feature engineering to do relative joint positions and velocities, and we found out that our accuracy reached 81 purpose when we use the connected neural network. Then we did the short classification using for CNN. Then we used ResNet 50, Efficient Net BU, and Mobile Net V2. We used these four training models, and we changed the hyperparameters. That means we did hyperparameter tuning, and we found out the accuracy to significantly increase from 23% to 66.33%. So now we'll use see the code of the short classification. So first of all, we extracted the images, the frames from each of the videos, and we used 7,820 videos. Then we extracted the frames from it. Then we augmented the data, transformed the data. We did the data classification, and then we used four different types of models to do it. First of the model was CNN, where we found the accuracies to reach around 53%. We started with 23, but by using hyperparameter tuning, we made it reach 53. Then we had two different other models. Then at last we reached 63.52 when we did data augmentation also. This is the confusion matrix, and we also predicted and the images, the true images and the predicted, and we found out that we are getting good accuracy. ResNet 50 was also used for the same thing, and our accuracies increased significantly. The highest accuracy which we found was in ResNet, and the last efficient 50 we did, and mobile net V2. And we saw the accuracies reaching 66.85. That is the max accuracy which we achieved.
So, and then I would go to the our main approach. Our main approach use open post to extract the like post features of the player. So here's the code for the post. What we did was we first extracted all the images. For this, we have used a different data set in which we had five different types of shot: lift, smash, not net shot, and other two. So we have trained our model for 100 epochs, and we got a accuracy of 80.9 on test data set. And for training data set, we got 81% of accuracy. And using YOLO V8, we tried to do a pose mapping of the player. Using this, we were classifying the different types of shot. Here's the output of our classification model. So, like as you can see, it identifies whether the player is lifting the shuttle, or whether he is trying to play a net shot, or whether he is trying to do a smash, and all those things. And then we went for okay. And then we come to the tracking of shuttle tracking and player detection part. As the shuttle is small and it moves quickly and often blurs in the video, while players can block each other, making tracking very tricky. So we need to come overcome these challenges. So we used YOLO V8 on frame-wise shuttle player detection, and we refined our trajectories via Kalman filter for velocity thresholds, and player identification was done using special heuristics. Now I will show you the output of our player detection part. First, I will go through the code. So our player detection and shuttle tracking part is handled by this main.py file. In this, we are loading the player tracking best model and shuttle tracking best model. These are basically trained using this train.py file, in which we are loading our dataset and then training based on YOLO V8. So I will run the main file. So as you can see here, our output underscore video.mp4 file is saved. First, I will show you the input file. So our input was this 18-second video of a rally between two players. So as you can see in this, our model is able to track player one, player two, and as well as the shuttle, along with the trajectory of the shuttle. And then we went on for code detection and homography estimation overview. So as you know, that the court layout is crucial for understanding where the players and the shuttle are positioned. We started with YOLO V8 for our course localization. Using YOLO V8, we first detected whether the frame is containing a court or not, and then using clay, we enhanced our contrast by handling the lightning changes and all those things. And then we extracted our code lines using canny edge and how detection and transformations. Using Ransack, we created a homography matrix to transform the code into bird eye view, achieving accuracy of 87% measured by intersection of unions. And then we did temporal smoothing to reduce the jitter by 20%, ensuring a stable view. And this top-down perspective is perfect for studying player positioning and short strategies. And now I will show you the output for code detection. So as you can see here, we have used YOLO V8 to train on our dataset, and then we have tried to predict whether the frame is containing a code or not. So it has predicted that this frame contains a code by 90%, 98% of accuracy. In this way, we have first detected the code, whether the frame is containing a code or not, and then using computer vision techniques and Lasnik and Kenny Edge and Ho transformations, we detected the code lines. As you can see in this image, like there are some other lines are also detected as code lines. To remove those lines, we have used computer vision. So what we did was we first converted our image into gray image, and then we binarized the image, and then we thinned the image to get one pixelated lines in the images, and then we found out the horizontal and vertical projections. As you can see here, these are all the horizontal projections of horizontal lines. So what we did was we basically found out where like wherever horizontal lines will be present, there will be a bin, and in this way we also found out the vertical projections. So based on that, we use Harris corner detection to identify the corner points, and then we draw the homography lines, and then also we have detected the homography points in such a way that we can do the better positioning of players in shuttle. And so in summary, our project combines cutting edge AI with computer vision to revolutionize badminton analysis by tracking movements and mapping the code and classifying different shots. We provide tools to help players improve, coaches strategize, and fans appreciate the game nuance. This work could be extended to other sport also, opening new possibilities for AI in athletics. Thank you for